Okay, so we've got two springs. There, both when you've got tension. I always write down tension, and then given lambda of both of them, so lambda x over L, and this one T equals lambda x over L. But there was going to be different lambdas and x's. And so what have we got? We're told the right hand one is 0.5 meters long, and it said that its equilibrium 0.6 meters. So that's gone down an extra 0.1 meters, and it's hanging in equilibrium. This one here, it's 0.4 meters, and therefore this bit here is going to be 0.2 meters. And lambda for the right hand one is 12, and lambda for the left hand one is 10. And obviously I've missed that one force on here, they're rather important, mg, the weight, but actually it says show that the weight is 7.4 newtons, so I'm going to call that W. And that's drawn my diagram for the first part. And so for I, it's hanging in equilibrium, therefore the upward force, I'm going to resolve upwards, and I'm going to have the upward force equals, that way I shown have the downward force, because that's the W equaling the upward force. So that will give me mg, which in fact is the weight, equals the upward force. So I'll do the left hand one. It's lambda, which is 10, times by the extension, which is 0.2, over L, which is 0.4, plus for the right hand one I've got lambda x over L, so lambda is 12 times by the extension of the right hand one is 0.1 divided by L, the natural length is 0.5, and that gives me that W equals 7.4 newtons. And then I've got to find the total elastic potential energy stored in those two springs when P is hanging in equilibrium. So elastic potential energy equals lambda x squared over 2L. And so I've got to have the two of those. So worth by putting in something, same what I'm doing, it makes much better, easier. I'm going to put the formula in, lambda x squared over 2L, often easy to forget the squaring bit. So it is the left hand one, lambda is 10 times by the extension, 0.2 squared, over 2 times L, so that's 2 times 0.4, and that's the left hand one done, plus the right hand one, so that'd be 12 times the extension squared, so 0.1 squared, over 2 times 0.5, and that equals 0.62 energy joules. Right, now part 2. I've got to show that it's simple harmonic motion. So simple harmonic motion implies and is implied by, I need to get x double dot equals minus n squared x. That's what I'm after showing. In order to do that, I need to have an extension, an acceleration on here, and I'm going to put my x, I'm going to drag it down, and a single-headed arrow here, and that x now is going to give me the direction, and so that says that my x double dot will be down here, and I'll get it to be negative, but which means we're going back to the center. It's held at a point 0.7 meters below, and therefore the amplitude will be 0.1, and therefore the right hand string won't go slack, because it will get up exactly to the extension. It's pulled down to 0.7, so therefore it will go up to 0.6, so it's gone up 0.1, and it will go up 0.1 further than that if it's in simple harmonic motion. So we've just got to show that bit now, and let's have a look. I need to be resolving downwards, and I'm going to have resultant force equals mass times acceleration. And what have I got going downwards? I've got mg, or the weight, which I've just shown is 7.4 newtons. So I've got 7.4, and that's the only thing going down. So I've got to have the negative tension on the left hand side. So it's minus lambda times by my extension on the left hand side is not just this x, it's the 0.2 plus x. So 0.2 plus the x, and that's lambda x over L, so that's 0.4. I've got tension on the right hand spring going upwards as well, so it'll still be a negative, and that'll be 12 times 0.1 plus x over 0.5, and that equals the mass, which will be 7.4 over 9.8 times by x double dot, and that will give me 7.4 minus, multiply this all out, 2 plus 10x over 0.4 minus 1.2 plus 12x over 0.5, and that equals 7.4 over 9.8 x double dot. Multiply this all out, and or do 2 divided by 0.4, etc., and that gives me 7.4 minus 5 minus 25x minus 2.4 minus 24x, and that equals 7.4 over 9.8 x double dot. I've got 7.4 minus 5 minus 2.4 is nothing, so it gives me minus 49x equals 7.4 over 9.8 x double dot, and that gives me x double dot equals minus 2401 over 37x. That's by using my calculator, and that's what n squared is, and so n equals the square root of that, which is 8.0555. It's another 5 as well, dot dot dot. Okay, and it says, I'm showing it, therefore that's simple harmonic motion, and find the period. Period equals 2 pi over n, which equals 2 pi over 8.05, which equals 0.077998126, and that's showing found the period. Yeah, always just check you have done all of this. I'm showing it so it's simple harmonic motion because I've got x double dot is minus n squared x, and show that throughout the subsequent motion. I've also shown the string won't go slack because the amplitude is 0.1, and that's therefore question 3 done.